But you see, groundwater planning is a dynamic document. It has all kinds of issues that keep coming along and dealing with. There's no GAM model for any aquifer in the state of Texas. The Panhandle Water Planning Group took part of their money and had a groundwater availability model developed for the Panhandle area, for our area. That was the first one in the state of Texas. Now they have those for all the major aquifers in the state of Texas. So what this does is predicts the saturated thickness over, and we can do this on a year increment or 10-year increments or whatever. I'm going to show you a model run here. This one was updated in 2004. Now the new model, we just saw the preliminary plans of it on Tuesday this week, so I don't have the one that's updated for 2009, but this will be similar to the one that you have. Now, the darker blue means the greater saturated thickness. And as we run through time here, as the color lightens up and changes to white, that means that area we've used all of our 50% allocation that we have available in that area. They'll go in 10-year increments, and up to the year 2000, that's all historical data. But once you get past 2000, that's predictive data. And so this is all going to run automatically, so I explain to you what. Okay, here we go. This is 1960. Just watch it as it changes colors through time. Remember, up through 2000 will be historical data. So those are actual numbers. And you'll start seeing some prediction numbers. You start seeing Dalton County, some white areas show up, and some other areas. Remember, this is a planning tool. Gives us some idea of what some of the changes are happening in some of the areas they're irrigating. And you see how that's changed. So this is a tool that we use in planning to look at this and see how much water we would have available. Well, what that does is that helps us develop where these needs are. And when we've done this, in the irrigated agriculture area, we've identified 6 counties that are going to have a water need over the next 50-year period. And those range from 849 acre feet in some counties to over 140,000 in some others. Municipal rural water needs, there's 15 cities or rural water areas that will have water needs. And there's 5 what we call other needs. This could be industrial, mining, power generation, something like that. Again, focusing on the irrigated areas, these are the 6 counties that were identified as water shortages, and in which year we would have those shortages. You see some of them show up in 2010. And so, but you see how those, we predicted those have changed over time. Now, to develop some strategy, we have to recommend a strategy for meeting that need. And so these are some strategies that we worked on. Now, I'm just going to take irrigation equipment change. And we estimate that we can save a little over a half acre foot of water per year if we implement that change. And what that's talking about is changing from irrigation to some type of leafless system, or if you've got a high pressure sprinkler, or you change it to a low pressure system, or you change the elevation of your drops on there, or you go from sprinkler to drip. This is what we're talking about in equipment changes. We're doing that. Now, here we've estimated that 80% of our producers have already done this. And that in 10 years, another 5% will do it, then increase. And you see the number, this is the adoption rate out here. Now, we've included here a biotechnology adaptation. This is the drought-tolerant crops we were talking about this morning. If we had those, of course, we have no one doing that right now, but maybe in 10 years, 50% of us will be using that, and how that would be. Well, this is gives us some idea of the water. Back to the equipment area, we see we could save over this 50-year period almost 4 million acre-feet of water if we did this. But if you look at biotechnology, about 10 million acre-feet of water we could save. And then we've got some, the percent of irrigation demand that's included there, what it would cost to do that, and then where's the plus or minus effect on the social economic. Is it a positive or is it a negative impact? There's other strategies here that we've included. Conservation tillage doesn't really affect the water amount very much, only 1%. We can get a large water savings right here if we change crop type. That's like it went from corn to wheat or some cotton, some other crop like that. Change from irrigated dry land, we get some savings, but it's a real negative impact. So this is the kind of analysis we've gone through looking at some of these strategies. Now, this is Sherman County, and I've taken this county and just looked at what we might do. This is a shortfall, and if we implemented that in about 2020, we could come up and we could cut that deficit down to only 19,000 acre-feet if we adopted all of those strategies at that percentage that we're talking about of adoption. And then in about 2030, see, we would come back and remove the shortages if we did this. Now, I have precipitation enhancement in here, and it's whited out. We've included that because there is some scientific data that shows there's some benefit to precipitation enhancement, but it's not we don't think it's going to be available in Sherman County in the near term. So we've included our analysis, but it's not in the total here that we have here. Now, just another example, this is Hartley County. This is a larger deficit. Again, you see these, but even in Hartley County, if we adopted all of this in this planning cycle, we never see that we're going to meet all of the demand that we have. So this means that the only way you do that is to stop irrigating in that particular county. So this gives us some ideas. Now, remember, this is a planning document, so this can help us see into the future of what we're talking about. And I think it's looking at data like this at the irrigation conservation district boards that look at this data and see this, and they say, well, we've got to do some bold step forwards because we're in charge of making this thing work from a policy standpoint. So that's what we're talking about here. But this is just the process that we go through and looking at these different strategies for trying to meet the demand that we see. Well, some upcoming activities of the water planning group. Again, we have to have our draft in by March 1. Sometime this spring, in April or May, there'll be a public hearing on that plan where you can come and look at the plan, talk about it, provide your input into that plan. Then we will revise that initial draft and plan, submit it to the Water Development Board by October 1st. And then that revised plan, we'll have a public hearing on it sometime in November. And then January the 5th, 2011, we have to submit the final plan.